In this lab, we will continue with the time series data analysis of the public transport network in Auckland. We are going to look at the missing data, and we are going to apply seasonal mean method to fill the missing values. So this is what we are going to do, and then we are going to compare the previously computed missing values from various methods. So one was we used forward filling, and we used backward filling method, and we used the interpolation of kind linear and of kind cubic, and we used KNN mean method as well. So we are going to in this lab we are going to use seasonal mean method. So and then we will compare the error of precision computed from the mean squared error. So seasonal mean definition: seasonal underscore mean of TS, and TS is the missing value. So missing data frame, and in that there is a column named value. So we are going to use that value in place of TS, comma N. N is we will put it equal to 12, and learning rate we will put it equal to we will use 1.25. We should, yeah. So and then we compute the mean of corresponding seasonal periods. TS is one-dimensional array-like of the time series, and N is the seasonal window length of the time series. Let out equal NP dot copy of TS. So we are making copy of the missing value. For I, val in enumerate of the TS, if NP dot is nan of value, so if the value is missing, then TS, let TS underscore Cs equal TS square bracket from I minus 1 to minus n. So this is minus n, which means going backwards, the previous seasons only. If NP dot is nan of NP dot nan mean of TSCs. So we are finding the mean of these TSCs of the previous sessions, previous 12 values, and if it retains nan, if it retains missing, then let TSC is equal to NP dot concatenate the previous TSI minus 1 up to minus n, so the previous 12 values, comma TS bracket I colon n. So 12 values forward. So previous 12 values and forward 12 values. Out, let out bracket I, so for that missing value, equal to NP dot nan mean of TS underscore Cs. So we are filling that missing value with the mean of the seasonal values times learning rate, and we return out, and then we plot. So let missing seasonal underscore mean, so we are creating new column, equals seasonal underscore mean which is we are calling the function seasonal underscore mean of missing dot value. So these are the inputs. Inputs are missing dot value, comma, n equal 12, comma, learning rate equal 1.25. Then we compute error. Let error equal np dot round of mean underscore squared underscore error of complete bracket value, comma, missing of column seasonal underscore mean, comma 2. So we are computing the mean squared error and rounding to 2 decimal place. Then missing of column seasonal mean dot plot bracket title. So title equal seasonal mean bracket MSC colon plus HDR of error plus, comma, x equal axis bracket 6, comma, label equal seasonal mean, comma, color equal blue, comma, alpha equal 0.5, comma, style equal dot dash. Now when we run this, we get these values here, and then for comparing we can see the mean square error is 0.4, which is quite high, and the best fit is still sitting at a linear fill of where mean square error is the lowest. So let's set the limit. Let's say x is 0 dot set underscore x limit of from 1st of December 2009 to 1st of February 2013. Let's run that. We need to load the data again, the raw data, and then we see that the missing data is the red one and the available data is the green one, and linear fill is 0.13. Okay, so now what we're going to do is we're going to do it differently. So okay, so let's run all the previous cells. So we get a graph. Now let's run this missing dot value. So we get this. Now for let out equal np dot copy of missing dot values, that prints the values in one-dimensional array. So for I comma val in enumerate missing dot value, let's print I comma val. So that prints the index number and the value. And then for I comma val in enumerate missing dot value, If np.isName or val, then print I comma val. So let's run this. So this will print the indexes and for the missing values. And let's print the missing dot value dot head of fish 20 values. So then missing dot value of bracket, square bracket, 10 colon minus 2. Okay, dot head of fish 10 lines. Let's print that. And that prints this. Now what is happening is that a missing value 10 colon minus 2. So we will read the position 10, 2, 4, 6, 8, 10, and then from there we will read every second value. So 5.0818, 5.4384, and then 3.0695, 4.3954, and 3.83803, and then 4.0834. Okay, so let's run this command. For I comma val in enumerate of missing dot value, if np dot isName of value, if the value is missing, then let ts cease equal missing dot value of I minus 1 colon minus 12. Print missing dot value. So what this does is that if the value is missing, then let TSS equal from that missing value, the value before that, and we'll read all the 12 values before that. And we let TSC is equal to that. And and now we are printing missing dot value from 0 to I plus 1. So if that value is missing, then we are printing missing value from 0 to index 0 to index I plus 1, comma, and we are printing ts underscore c's, which is from index I minus 1 backward the 12 values. Backward 12. So in the value after every 12 values, the value in every 12 values. So we will go in steps of 12 and we will take the values. So and then it prints. So for example, this value over here was missing. So we have printed from index 0 up to that value, up to the missing value, and then the ts underscore c's will go from index I minus 1, so which is 4.3954, and the next value will be after 12 values, but we don't have 12 values backwards, so that prints only 4.3954. And for the second round there is a second missing value here. So what the TS seasonal does is that takes 4.4494 and then counts 12, so takes another value in the 12th location. So 2, 4, 6, 8, 10, and 12. So the 12th value before that is 4.3803. So 4.3803 is here, and we don't have 12 values before 4.3803, so that stops there, and so on. So okay, um, okay, so it's this one. And now in the next step, we will pass the command for I, val in enumerate of missing dot value. If np dot is name of value, so if the value is missing, then let ts underscore sys equal missing dot value of I minus 1, and then we are taking the values in every 12th location in previous seasons. We print np dot mean of ts underscore sys. So if there is a missing value, then it doesn't take it into account, and then it takes only the values that are present. So if np dot is nan of np dot nan mean of ts underscore sys, so which means that if all the previous values are missing, then print missing dot value bracket from I minus 1 up to minus 12, comma, missing dot value from I to 12. So we're taking values in every 12th location backwards, and values in every 12th location forward. So when we run this, we get this. So we are printing. So we see that np dot nan mean of TSCs is all a value. There is no missing value. So which means that all the previous values contain values which are there are some values in the array which are not missing. So that's why we are able to find the average, which doesn't say nan. So let art equal np dot copy of missing value from I, val in enumerate of missing dot value. If np dot is nan of value, so if the value is missing, then let ts underscore sys equal missing dot value of square bracket I minus 1. So the value that is missing, so we are taking the index location before that, and we are taking all the values, all the 12th value. So we are looking at the previous seasons. If np dot is nan of np dot nan mean of ts underscore sys, so if the mean of the ts's is missing value, so which means that all the values before is missing, all the values that are taken seasonal values previously is missing, then let ts underscore cs equal np dot concatenate of square bracket missing dot value of the values, seasonal values before that index location, and all the values, all the seasonal values after that index location in every 12 location. So print, so we are over here we are printing the printing out, and index location is for I. And now let out of square bracket I equal np dot nen mean of ts underscore c's. So this is the mean of the seasonal, the ts underscore c's. So if there is missing value, then it doesn't count, and then multiplied by the 1.25. This is the learning rate. So print out bracket I comma a new line. So what happens is that we see these values over here. This is, for example, nen. Then the computed value is 5.494249, so on. And for each of these nen values, there is a value computed. So and then we take those out values, and then we find the mean underscore squared underscore error of complete values and out, and we get 0.4038, so on. And if we do np dot round of these values, comma 2, okay, so we need to run this again, and then we'll run this again. So that gives to 2 decimal place is 0.4. So now we for all those functions that we did, we put it as a definition. So definition, seasonal underscore mean of ts, and ts is the missing dot value, comma n is 12, learning rate is 1.25. so we'll remove this equals 0.7, and then we put the function over here, and then what we do is that we create a new column, miss seasonal underscore mean, in the missing data frame, and we let it equal to seasonal underscore mean. So we are calling the function seasonal underscore mean of inputs are missing dot value, comma n equal 12, comma learning rate equal 1.25. Let error equal np dot round of mean underscore squared underscore error of complete value, comma missing seasonal underscore mean. So we are computing the mean squared error of those two values, and comma 2, which is we are rounding those values to 2 decimal place. Missing of seasonal underscore mean, so the new column that we have computed, dot plot bracket label equals seasonal mean bracket MSC colon plus str of error plus comma x equal axis alpha equals 0.5 style equal dot dash, and then we'll just comment this line. Access.legend open and close bracket, access.set underscore title of filling the missing values with various methods, plt.show open and close bracket. Let's run that. And we see that the seasonal mean, which is the light green one, which is over here, there are some new values that has come in. And again, comparing the mean square error, the mean square error for linear fill is the lowest. So that's the best method. Interpolation linear method is the best method to fill the missing values. So if we put the x limit, if we set the x limit by passing the command access.set underscore x limit of square bracket from 1st of December 2009 to 1st of February 2011, then we run this and we get this. So we see that this black line is for cubic fill, and this orange one is for linear fill. This blue one is for forward fill. This light green is for seasonal mean. This red one is for available data. And this light red one is KNN mean. And this dark red one is backward fill. So so these are so the rest of the values are on top of each other, which are same values, but these in this range the values are different, and the best fit is for linear fill. Then we read the data, raw data again in this command because we have created some new columns, and then we have already gone through this in the starting, so we'll run this again. And in this one the data is plotted on separate axes by inducing plt.subplots. The row equals 7 and column is 1, and share x equal true, and fixed size equal width 10, height 12. So, and then for each of these plots we have named for which axis it will go to. So axis 0 is for the actual values, and axis 1 for the forward fill, axis 2 for the backward fill, and axis 3 for the linear interpolation, axis 4 for cubic interpolation, and axis 5 for KNN mean method, and axis 6 is for the seasonal mean. And we get this. So which infilling method to use? The interpolation method, the linear interpolation method is to be used because it gives the lowest mean square error.